Welcome back to my daily work day, school day, weekly, daily broadcast for the SAT problems from Khan Academy. So we're going to continue today with solving systems of linear equations for my Facebook Live audience. Once again, you will not see the share screen. You'll just basically be able to hear me talking through the problems. If you want to indeed see the problems and solve them with me so you actually can see what's going on, go to my YouTube channel and you can log on there. If you're not doing it live, you can do it after the fact. The videos will be uploaded and you can work through the problems there. Okay, now let's get down to business. Don't have a ton of time today. Once again, race against the clock to get to work, get to school. All right, so let's first go ahead and get the problems all set up, and then we'll come back and we'll hit the share screen here. Let me clear the board. And it's pretty cool. By the way, if you guys check out my music videos, I'm excited to announce that I didn't think I was going to be able to, wasn't sure if I was going to be able to pull it off. It looks like I'm going to be releasing a music video on Pi Day, which is March 14th. So make sure to check that out. March 14th is National Pi Day. It's the one day of the year that's actually a national math holiday, which is really funny. And to commemorate that holiday, I'm making a music video all about pi, the number pi, not the actual food. And it's going to be really, really cool. I'm excited about the music. And so we're going to shoot it next weekend. So make sure to check that out. Okay, let's go now to the share screen. Okay. Here we are. So we're going to start with this guy first. Let's make sure we've got this guy out of here. Keep this here. All right, let's begin. So it says question number 1. And solving systems of linear equations, these are just like basically if we want to visually represent them, they're just two lines that are going to cross, and we got to find that intersection point. And it's got two variables, z and w. Oh, in this case, it's actually got k, but k is a constant. It's always got two variables. For which value of k are there infinitely many wz solutions? Now, this isn't your run-of-the-mill linear equation problem. It's got a little curveball. Well, when do problems have infinite solutions? That's the question that we're really trying to figure out. It's when they're literally the same line. They're overlapping lines. So we need to figure out what value of k is going to make this equation have infinitely many solutions, basically meaning where is it going to make it overlap? So this is how we kind of got to figure it out. And actually, to be honest, I can already tell you that it's not going to work. There's no value of k that's going to make this happen. I'll show you why in a second. So let's say we even were to pretend like, let's say we're even going to isolate z, okay? Even if we did that, the first equation would be z equals, let's see, negative w plus 3 plus k. And if we were to, so I just moved these two guys over to the right side, right? I subtracted w and I added 3. Let's look at this one, 6z minus 10w. So we're going to add 10w to both sides, right? Add 10w here. So this one will be 6z equals 10w plus 8, and then divide both sides by 6. You got to divide every term by 6. And we get z equals, what is this, 5 over 3 plus 8 over 6, 4/3. Why can we never make these two lines the same with k? Because we have a slope here of 5/3. And there's no way that we can ever change the slope of this first equation. We can never change what's multiplying negative w because there's no constant there. There's nothing there that we can use to modify. So no matter what we make k, these lines will never be the same. They'll never overlap. Therefore, there's no way, there's none of the above. There's no way that we can get a value of k that's going to give us infinite solutions. So let's go ahead and let's go back here and just make sure we're right. We're going to answer D, none of the above, and we're good. Okay, let's go on to the next one. Oops, hold on 1 second. I think I hit the wrong button. There we go. Copy this. All right, let's look at this. Which of the following will result exactly one solution? They want which of the following choices of A, this is a similar thing. We want a value for A where we're just going to get one solution, meaning they're not going to be the same line. It's not going to overlap. And it's going to, but it's just going to, all we need for one solution is the slopes to not be the same. If the slopes are different, then they're only going to intersect in one spot. The only problem is if they have the same slope and the same y-intercept, they'll overlap and they'll have infinite, or they'll be parallel, meaning the same slope but different y-intercept. So all it is we just have to get the slopes to be different. Now again, this value is not even affecting the slope. The only way it would affect slope is if it would be multiplying x after everything is isolated. But I'm just going to show you why this is true. So my assumption is the answer is going to be A. But even on a test, I wouldn't even jump to A, where A can be any number. I'd still go ahead and isolate. So let's start up here. We got negative 5x, because I always want to get it into y equals mx plus b. We're going to add 5x. Add 5x to both sides. This goes away. We got negative 4y equals 5x plus 2a. Divide everything by negative 4. Y equals negative 5/4 x minus 1/2. So here's our slope for the first equation. It's negative 5/4. Now let's look at the second one. We've got 4x minus 5y equals 2. We're going to subtract 4x, subtract 4x. Oh, wait, I forgot the a. This is 2a, 1/2 a. And then this goes away. We got negative 5y equals negative 4x plus 2. Divide both sides by negative 5. We got y equals 4/5 x. It becomes positive, right? Negative and negative cancels out. This stays negative because we only have 1 in this, 1 negative here, so that's going to stay negative. Now, I did this just to show you something. Here's the slope. The slope is different from this guy. What did I say? To have one solution, they just need a different slope. The y-intercept is now irrelevant, meaning A can be any number. No matter what A is, we're going to have one solution. It's not going to change anything. So we can go ahead and come back to this. Let's make sure we're right. Make sure I don't misunderstand anything. And we're good. I hope that makes sense. All right, now it says, let's do this next one. This one, definitely from the quick glance I had of it, it looks pretty tough. Oops, let's see. Once again, as I've mentioned before, I never see these problems beforehand. I'm solving them in real time with you guys. I'm looking at them for the first time, and that's part of the fun. So I'm learning it along with you guys. So we have here 1/2 x plus 3. What does it say? Consider the systems of equations above. Which of the following statements is true? They're crazy, right? These are really, really intense. Now they're saying there's only one solution. There's only one xy solution, and x plus y is negative. There are infinitely many solutions. There are no solutions. I'm just guessing it's between A and B just because they're both similar. But let's see. So again, the one solution comes into play with our slope. Oh my gosh. Oh, you know what they've done here? They've put this into, no, it's not point slope. I was going to say it's point slope, but it's not point slope. Let's see. All right, this is, the one way to do this is to literally multiply everything out and get it into slope intercept form. But that's kind of a little bit of, a brutal process. I'm just trying to see if there's a shortcut. And we could get this into, all right. If we get this into, we could get this into point slope, and that'd be a little faster. So I'm going to do that. And is that, well, let me think here. Or, hold on, there might be another faster way. If we did, and let me think what else. -2. They both don't equal -2. All right. There might be a very fast way to do this that I'm missing. So I'm not sure. I'm going to do it It's a bit of a long way, but I'm going to do it the way that I know will work, where I'm just going to sort of put this into slope-intercept form. So I'm going to say 1/2 x plus 2, 6. Actually, shouldn't take that long. Minus 1 equals 2y plus 2/3 minus 1/3. And then this becomes 2y plus 1/3, right? I'm just reducing the fractions. And then minus 1, 2, 6 minus 1 should be negative. This is 2, 6 is just 1/3. I'll just write 1/3. Make it simpler. 1/3 minus 1 is negative 2/3. Negative 2/3. Fx plus negative 2/3. We'll move this guy. Let's add this to both sides. Let's move this over here. 2/3 plus 2/3. I'm just going to do it because it keeps it positive. Now we have 1/2 x equals 2y plus 1. Let's move this over here. Negative 2y. And then I'm also going to simultaneously move the 1/2 x over here. Now we get negative 2y equals negative 1/2 x plus 1. And we're going to multiply both sides by, or sorry, divide both sides by negative 2. Excuse me. So we get y equals 1/2 divided by negative 1/2 divided by negative 2 is positive 1/4 x minus 1/2. All right. So there's one line. And let's take a look at this guy. So let's do it over here. We got x minus 2. I'm going to remove the parentheses. Minus 4y minus 2. We got to distribute that negative 4 equals negative 2. So then I'm going to bring it up here like this. We've got x minus 4y minus 4 equals negative 2. I'm going to add 4, x minus 4y equals 2. Let's move the x over, negative 4y equals negative x plus 2. And then we got y equals, and then it's going to be positive 1/4 x. I'm doing it fast, so hopefully I didn't make any mistake. We're dividing by negative 4 minus 1/2. Oh, look at that. I was wrong. I was wrong with my little presumption. It just seemed like it was going to be between a and b. They're the same line. So y equals 1/4 x minus 2. So they should have infinitely many solutions. And just make sure I didn't do anything wrong here, because that's interesting. 4, negative 4, minus 2. And then we add, that goes to 0, that goes to positive 2. And we're dividing by negative 4, negative 1/2, just like there. Negative x divide, yeah. So the same line, there's infinitely many solutions. Like I said, I'm really curious about this one because I feel like there might have been a way to solve this fast, but maybe I'm wrong. Maybe it's a hard problem and it's going to take that much work. So let's make sure we're right here. Make sure I did all that isolation correctly. Yeah, and just let's see what they say. Let's see how they solve it. Nah, see, they solved for x. Oh, they did substitution. Interesting. Yeah, and substitution. So really what's going on here with systems of linear equations, I actually didn't even think about that. I think that would have been a little faster. We're often, to find the solution, we're subbing it. We're doing some substitution. Now, I would have done substitution had I realized they weren't the same line afterwards, because then you need to find the solution. Is it what is x and y? And it was asking just if their x plus y is positive or negative. But since I didn't need to do that because I realized they were the same line. But they just went straight to substitution. They isolated for x, and then they plugged it into the second one. And they got this equivalency of 1/3 equals 1/3. You get something like that. It means anything goes. All right. That was a really interesting question. You know what? This one, let's solve the way that they did last time. These are pretty high level. I'm curious as to why they're giving such difficult ones right at the beginning, because usually they usually like sort of ease you into these problems. But let's go ahead and go for it. You know what? I am really running late. I definitely need to leave. But let's try and finish this up. So let's see here. We could let's isolate for y. Okay. And we're going to, let's maybe isolate for x. Okay, let's isolate for x in this first one. So we have 2/3 times x plus y, 1. And I'm going to straight up, right off the bat in this first step, I'm going to move 4/5 y to the other side. We're going to add it to both sides. Equals 4/5 y plus 1/3. Multiply both sides by 3/2, right, to get this out of here. And then we get x plus 1. 3/2 times 4/5 is 12/10. 12/10 y plus 3/6. I'll reduce the fractions in a second. And then we minus 1 from both sides. Minus 1 from both sides. So now x equals, I'm going to change this to 6/5 y. And this is a 1/2 minus 1, which is minus 1/2. Now we can take this. This is what x equals, and plug it into x over here. So now we've got 2/5 times 6/5 y minus 1/2. And I'm going to go ahead and, yeah, I'll keep that there. Why not? Let's see what happens here. Plus 1/3 times 2y plus 1 equals 1/5. All right, fractions. This is a little crazy, but it's doable. 12/25 y minus. This will be 2/10, so I'm going to say 1/5 plus 2/3 y plus 1/3 equals 1/5. Now let's combine like terms. Yikes, these are not friendly numbers. And 2/5 times 6/5 y. Did I make sure I did all this right? 6/5, 4/5, 12/10. And it looks right. So this is going to be, man, these are not very good. So we're going to have to combine this into 75ths. Blah. All right, so 75ths, or I can multiply everything by 75 and get rid of all these denominators. Let's do that. So I'm going to multiply this whole thing by 75. Right? This becomes I'm skipping these steps because okay, so this reduces to 3, right? So that's why I get 36y minus 75 over 5 is 15. Plus 150 divided by 3 is 50y. Right? Hope that makes sense. Plus 25 equals 15. Much easier numbers. 36y plus 50y is 86y. Negative 15 plus 25 plus 10 equals 15. 86y equals, subtract 10 from both sides, 5. And then y equals 5/86. Oh my. All right. So then since y equals 5/86, we can plug that into any of these equations and we can get our x value. Let's plug it into here. So 6/5 times and I can, so this will be 30 over, oh no, these cross off. This becomes 6/86, which is 60, it reduces to 3/43. 3/43 minus 1/2. And that would be, actually, you know what? I should have done this like this. Let's go back to this. So 6/86 minus 43/86. So that's negative 37. X equals 7/86. Therefore, we know that I did it like this because now we know x plus y is actually negative. So here's the solution. There's one solution. And these two guys, God, these are just insanely difficult fraction problems. This plus this is going to be negative, right? Negative 37/86. It's a bigger absolute value. So the negatives win. Let's see if I did this correctly because that was pretty crazy. Did they give? It's the same. Negative 37. I can't believe they're giving these problems because that is. I would expect that to be one of the last questions on an SAT, amongst the last ones. So it's kind of interesting. Okay. Let's end with number 5. Let's just do it. Gotta get to school, but we'll rock this out here. All righty, final one. Consider the systems of equations. How many PQ solutions does this system have? So we've got 1.7, it's the same exact thing. We can do a little substitution and make this pretty nice. Or we can also, let's see, this guy has no slope intercept. And let's see if there's a faster way. Oh, 1.7.17. Okay, I think I see a way to do this faster. 0.3445. Okay. We can change this one up top. So I'm gonna make life a little easier. 1.7, and this is, you could use a calculator on this one. Again, like I don't have one with me, so I just kind of go with it. We can divide everything by 0.34. And I'm pretty sure, okay, both sides by 0.34. This is going to be nice because 0.34, I believe, goes into 1.75 times, right? 5 times this. So this ends up becoming, you can verify this on your calculator, this ends up becoming 5p minus q equals 0. And guess what? That means if we add q to both sides, right? Add q to both sides, we get 5p equals q. Now let's just do some nice substitution, right? We just plug 5p in for q. So let's do it over here. 0.17 times 5p plus 1 minus 0.85 times p minus 1 equals 0. And this becomes 0.85p. Again, use your calculator. I'm just doing the arithmetic in my head. Plus 0.17, 0.85p. Plus 0.85 equals 0. These guys cancel out, right? And then 0.17 plus 0.85 is 1.02. Now, look at this. When you get something crazy like this, 1.02 equals 0, it's not true. It's not true. So if we get an absurd conclusion like this, it actually means that there's no solutions. There's 0 solutions, which means that these lines are actually parallel. They're not the same lines, they're parallel. I'm sure I could prove this, and I could show you, if we isolate it for P or Q, we could show this, but I don't have time to do that today. But that's the key. So now let's go back and see what happens if we actually, let's make sure this is right. Yeah, 0 solutions. And same thing. Now in this case, they actually isolated, right? They did it like the way I did the other problem instead of substitution. They could have done it either way. But yeah, 0 problems. All right, so that's it. I've gone way over the time that I should have gone. I got to go really badly. I'm late. So hope that was helpful, guys. And again, if you're watching on Facebook, make sure to, let me go back to screen share here. If you're checking this out on Facebook, make sure to go to my YouTube channel so you can see the screen share and actually solve the problems. And guys, on my YouTube channel, thank you so much for checking this out. And I'll see you guys tomorrow, same time. Take it easy.